Good morning, everyone. I wanted to remind you how to actually calculate the data for your lab report. I gave you a choice of picking either zebrafish or Elodea. So here I'm going to demonstrate how to do the calculations for the plant, for the photosynthesis experiments, and then I'll make another video on how to do the zebrafish. So I already had sent you a link to some artificially generated data. So if you picked the artificial light or the Elodea in the shade experiment or colored lights, I've just now added another fake experiment where basically I'm looking at the effect of photosynthesis in the early morning versus the early afternoon. And so for this particular demo, I've kind of changed the numbers slightly, but again, this whole experiment takes 30 minutes. And the other key piece of information you need is you need to know the volume of your plant. So if you will please get out your lab report and turn to page 69, you will see a reminder of how to actually calculate this data. And so what we are doing is we need to determine the micromoles of CO2 that got absorbed by the plant per mil of plant per hour. So a lot of students have been just calculating the mils of acid or base that were used, and that's not correct. You need those numbers to figure out the micromoles of CO2 that were absorbed per mil per hour. So if we're going to make this calculation, what we need to do is figure out how long did this actual experiment take, which is in hours. I gave you the information that it took half an hour. So if you take 30 minutes divided by 60 minutes, that would be a conversion to an hour, so that would be 0.5. So I'm going to go ahead and put 0.5 in here for that's how long it took. And then the other thing we need is you need to make a place for volume. So how many mils of water were displaced by the plant. If you remember, we put those into graduated cylinder, and then you had to do the same amount of plant for each experiment. So for this one, I tell you here, we use 2.5 mils of plant. So go ahead and put that in, 2.5, 2.5, 2.5. Okay, so in your lab manual, it says that in order to figure out the micromoles of CO2 over per mil per hour, you need to take VD, which is the volume of the plant in the dark, minus VL, which is the plant in the light. So here's our VD, here's our, this would be our, technically our VL1, we could say. And then this would be our other VL. We could call this VL2 if you wanted. Maybe I'll just write that in. So this is, say this is VL1, and then we'll say this is VL2. So we're going to have to do this two separate rounds, basically. So in order to do VD minus VL, you can do this on Excel. A lot of students are just doing it with a calculator. I don't care how you do it, but your numbers need to work out correctly. Okay, so you can see what I've done here is I've taken B10, which is the volume in the darkness, minus the volume in the light. So that's B10 minus B11. And again, you can do this on your calculator. And I've divided that by the time in hours times the milliliters. And so if you do that, you get some number like 0.6400, which is the amount of micromoles of CO2 absorbed per mil per hour for trial 1 for the plant in the light. Now I'm going to need to do the same thing for the plant in the sunlight. And so now again I did, sorry, there's a plane flying over. I'll pause it for a second. So for the plant in the sunlight at 8 o'clock a.m., I'm doing VD, which is this 1, minus the plant in the sunlight at 8 o'clock a.m., so it's 1 minus the 0.4, and I divide that by the time in hours times the milliliters, and so then that number you see here. So that is the results for trial 1, and then I need to do the same thing for trial 2 and trial 3. So you can again do that in Excel and just move your cells over, or you can do it on your calculator, whatever feels comfortable for you. I do not care. either way. All right, so now we have our results of the micromoles of CO2 absorbed per mil per hour for trial 1, 2, and 3, looking at sunlight early in the morning or sunlight at early afternoon. But what we need to do now is we're going to plot the average of these results. So go ahead and let's do our functions. So you just, again, you always hit equals and then average, and we are going to find out the average of the sunlight at 1 o'clock. And so that goes in there. And then I'm going to find the average of the sunlight at 8 o'clock. So you can just copy and paste. It's going to move those numbers down for you, or you can just do it again. Then we're going to figure out standard deviation. So again, you hit equals standard deviation. Go ahead, double click on that, highlight your 3 numbers. Then we will copy and paste. Okay, so now I have my averages, my standard deviations, and I also need to do a t-test. So here I'm doing a t-test of looking at, is there a significant difference looking at sunlight at 1 o'clock p.m. versus 8 o'clock a.m. All right, so again, the way we do this is we, that's smaller. We're going to hit equals t-test. And now it's asking, it's bolded array 1, so you're going to go ahead and select array 1. You then type in a comma, and now it's highlighting array 2. What's my array 2 data? It's the sunlight at 8 o'clock a.m. And then we already discussed in lab, you're always going to do a 2-tailed distribution and a 2-sampled unequal variance. And then close off your parentheses, hit return. And now we have our p-value, which is 0.09, which would say that this is not statistically significant. We have to accept the null hypothesis because this number is greater than 0.05. All right, so the last thing we need to do is we need to actually plot this data. So we're going to do a bar graph. We're going to do insert graph. All right, so here's what my graph looks like. We need to insert our error bars, so you just double click on your actual data. Whoops. I'm going to add chart element, error bars. This is all spelled out in your lab. More error bars, custom, specify values. And so now it's saying the default is 1 plus or minus 1, which is not correct. So we need to tell it what the error bars are. So we're going to do standard deviation, just highlight our rows right there. And then we need to do the plus and the minus. So we're going to go ahead and highlight those numbers there. Hit OK. And now our error bars have tightened up and look really good. So you can see the error bar for the sunlight was a little bit, should be bigger than that of the light at 8 o'clock a.m. And that's indeed what we see. This error bar is a little bit bigger than this error bar. All right. Last thing is you need to add all your data labels. So this average is not an appropriate title. We should have something like micromoles of CO2 absorbed by Elodea at varying times of day, something like that. We then need to add our axis label, so go ahead and hit axis title here, and that's where we need to write add micromoles of CO2 per gram times hours. All right, so it should look something like that. You can say this is time of day. And now that would be good to go. All right, I hope that was helpful, and please submit your analyzed data for 3 points extra credit, which is due by Thursday night. All right, take care. Bye-bye.